Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about a continuous uniform distribution, and it is also known as a rectangular distribution. The reason why is that because when you plot the graph of its probability density function, then the graph looks like a rectangle. Okay, and we're going to see the graph later on. Now, it is a family of symmetric probability distributions, and each member of the family, in this case, all intervals of the same length are equally probable. All right, we will talk about this later on. Now, let's move on to the probability density function of a continuous uniform random variable, and it is given by this one here. You can see we have two parameters, alpha and beta. Beta is the upper limit and alpha is the lower limit. Therefore, our random variable x here can take all the values between alpha and beta. And this is the mean of the random variable, of the uniform random variable, and this is the variance. And we're going to prove how these results are obtained. So that's what we're going to do next. But first of all, we're going to sketch the graph of a continuous uniform distribution where the parameters are described by alpha and beta. Here alpha represent the minimum value and beta here represent the maximum value. Okay, so what we need to do is we just have to sketch the y-axis, the x-axis. So here is the values of x. X is our random variable, and you can imagine this could be the point for alpha, where alpha is the minimum value, and our beta could be somewhere here. This is the maximum value, and this is fx, the probability density function, the value of probability density function, and it is given by 1 over beta minus alpha. So this is just a constant, and we know that the graph is going to be a straight horizontal line from alpha to beta, and this is how it's going to look like. We can imagine perhaps this is the point, 1 over beta minus alpha. So here we have the graph at point alpha, it doesn't include alpha, and at point beta. So the graph looks like this, and you can see that it looks like, or it resembles a rectangle. Okay, now of course if you differentiate, if you integrate the function, the probability density function, from negative infinity to infinity, the result is going to be equal to 1. And in this case, this here represents the lower limit. The lower limit is alpha. Oops, what's wrong? And the upper limit is beta. So if you integrate the function, which is beta minus alpha with respect to dx, well, this is a constant and you can take it out of the process. So we have 1 over beta minus alpha. This is beta and alpha. Here we have value of 1 dx. Of course, if you integrate 1, you will get x. So we have x, and we're going to later on substitute all the limits. And what we have next is 1 beta minus alpha. So the limit is beta minus alpha. You substitute that into x minus this one, substitute into x, and you'll be able to cancel both of them, and you get the result is equal to 1. So that's the characteristic of a probability density function when you integrate that with respect to its lower and upper limit. When you consider the lower and upper limit, the result is supposed to be equal to 1. Okay. Now another way of viewing this or getting this result here, we all have learned in calculus that when you integrate a function, so this is the function. The function here is just a constant, 1 over beta minus alpha. What happens when you integrate the function is you get the area under the curve. And you can see that in this case, the area here is just the area of a rectangle. And you can easily see that If you want to find the area of a rectangle, you just need to find what's the length and you multiply that with the width of that rectangle. Clearly the length here is this one, which is beta minus alpha. You can see that this is the length, and here is the width, and we know the width is 1 over beta minus alpha. So therefore length is beta minus alpha times with the width, which is 1 over beta minus alpha, and you'll be able to see that the area is equal to 1. So there are two ways of seeing this. One is through the integration process here. Another one is by simply finding the area under the graph, and it is quite easy to find because the graph here is just a straight line, and so you get the area of a rectangle. Okay, right, now let's move on to the next one, is the proving part. We're going to prove that if x has a continuous uniform distribution for x between alpha and beta, then the mean is given by this right here, alpha plus beta over 2. Okay, right. Now our starting point as usual is we're going to deal with integration because this is a continuous case, and we're going to have x, put it right next to our fx, dx. So here is the lower limit and the upper limit, and I'm just going to substitute what is the lower limit and upper limit. For x, we know that the lower limit is alpha and beta, so there you go, x, and then fx is 1 over beta minus alpha, so that's our fx. And this guy here is a constant, we can just take out from the whole process here, we can just put it outside. Next we have x dx, and this is quite an easy function to integrate, and the result is going to be x squared over 2 beta and alpha. Okay, next what we're going to do is we're going to substitute beta into x and alpha into x, and so the result is going to be as such. Maybe I can take out 2 outside, 2 is a constant, so I'm just going to put it right here. Okay, and so we have beta squared minus alpha squared. So that's what happened when you substitute beta into x and alpha into x. Now we can see that this becomes 1 over 2 beta minus alpha. Well, beta squared minus alpha squared is the same thing as having beta minus alpha and beta plus alpha. You can see it when you expand this whole term, it becomes beta squared. If you multiply that with that, this one is plus beta alpha, this one with this minus alpha beta, this one is minus alpha squared, and you can cancel out this term and you get back beta squared minus alpha squared. So that's what we're going to do. We're going to replace this guy here with beta minus alpha, beta plus alpha, and this can, you can cancel out this part right here, so it looks pretty nice now. And we have beta plus alpha over 2, which is the same thing as writing down alpha plus beta over 2, and this is the result that we're looking for. Okay, so that's it. It is quite easy to prove that part. Now we are moving on to proving variance of x. Okay, so for this one, we're going to start off with knowing that variance x is equal to expected value of x squared minus ex and you square it. And we have already obtained what is ex. Expected value of x here is this guy, so this is expected value of x. We have got the result, and we're just going to apply that later on. Now our job is to find what is this guy right here. Okay, so that's what we're going to do now. We're going to find what is expected value of x squared, and this is just going to be x squared times with fx dx from the lower limit to the upper limit. I'm just going to substitute the limits now. We have alpha and beta, x squared 1 over beta minus alpha. And again, this is a constant. You can just take it out from the whole process here. So we have beta minus alpha. Okay, so this is what we, oops, sorry. So this is what we have. And this is quite an easy function to integrate again. So we have x cubed over 3 beta and alpha. Now 3 is a constant, we can just take it out. So we have 1 over 3 times with beta minus alpha. And right there, when you substitute beta into x, you get beta cubed minus alpha into x, so you get alpha cubed. Okay, and there is a way to simplify this or to rewrite this part. So this guy here, so I'm going to rewrite this part here becomes, okay, let me just write down what is the result of that. So it becomes 1 over 3 beta minus alpha. So that part here becomes beta minus alpha, beta squared plus alpha beta plus alpha squared. Now you can try and expand this whole thing. Okay, you can multiply each of the term given, and you see that the result is going to be beta cube minus alpha cube. Okay, so we can do that together now. So beta times beta squared, beta cube, beta with alpha beta, we get plus alpha beta squared, beta and alpha squared. So it becomes beta alpha squared. Yeah. Next, we have negative alpha beta squared, negative alpha squared beta, negative alpha cube. So this part here can be cancelled with this one can be cancelled with this one, so you are left with beta cube minus alpha cube, which is this guy right here. Okay, let me just erase that part now. Okay, so by doing that, now we can just simply cancel out beta tolak alpha at the bottom. So we can cancel that out with this guy, and we can write down the result is beta squared plus alpha beta plus alpha squared over 3. So that's the result for expected value of x squared. Now we are going to find the variance of it. Okay, so maybe I just need to erase this part. Okay, let me just erase this one. Okay, so now what we need to do is we're going to find the variance now. So this one has been obtained as this guy, and ex, we already know the result is alpha plus beta over 2. So we're just going to apply the results that we got into the formula above. So variance x is equal to beta squared plus alpha beta plus alpha squared over 3 minus alpha plus beta over 2, you square it. So that's expected value of x squared. And we can try to simplify the result that we have here. Okay, so we are going to take out the brackets. So we have alpha squared plus 2 alpha beta plus beta squared over 4. Yeah. Make sure the denominator has a common value, 12 for example. So we're going to focus on the upper part now. So we have 4 beta squared plus 4 alpha beta plus 4 alpha squared minus 3 alpha squared minus 6 alpha beta minus 3 beta squared. Okay. Next, we can simplify that. For example, this one here, 4 beta squared with negative 3 beta squared. So it becomes 4 minus 3 becomes beta squared. Yeah, beta squared. Next, 4 alpha beta with negative 6 alpha beta. So that is negative 2 alpha beta. 4 alpha squared minus 3 alpha squared, so that is alpha squared over 12. And we know that this is the same thing. The upper part is actually b minus alpha, beta minus alpha squared over 12. You can try and expand this result if you don't know what is this about. So beta minus alpha squared, if you expand it, you will get, so here beta minus alpha, you square it, you will get beta squared minus 2 alpha beta plus alpha, plus alpha squared. This is actually plus, yeah, 4, sorry, my mistake, 4 alpha squared minus 3 is positive, so this is positive, and you get this result here, okay, this result here. Alright, so there you go. We have managed to prove that variance of x is given by this one. Now we're just going to apply the results that you have seen here to answer the practical question given here. Well, the time in minutes that Irene takes to check out at her local supermarket follows a continuous uniform distribution defined over the interval 3 and 9. So therefore, time in minutes is our random variable x, and x here has a continuous uniform distribution. This is the value of alpha, the minimum value. This is the value of beta, the maximum value. And the question is asking you to find Irene's expected checkout time. So when you talk about expected, that means you're talking about finding the expected value of x. Very simple, which is x times fx dx, and the limit is actually from lower limit to upper limit, and in this case is from 3 to 9. Okay, and I'm just going to replace, maybe I just replace straight away what is fx. So fx is 1 minus 1 over beta minus alpha, so that is it. Or that is one way of doing it, or if you want, you can also use the formula straight away. For example, this is what I'm going to do. I'm just going to use a formula straight away. This is one way, or maybe we can just try and do this one first. Okay, let us try and do this one first. So here we've got 9 and 3, and then we have x over 9 minus 3 is 6 dx, so we have 1 over 6, and if you integrate x, you get x squared over 2, 9 and 3, and that becomes 1 over 12, x squared 9 and 3. Next you will get 1 over 12, 81 minus 9, so 81 minus 9 over 12 is 6. Yeah, 6. So that is one way to solve this problem using the very basic approach of integrating x times fx. Now another way of doing it is we can just use the formula. So the formula says expected value of x is alpha plus beta over 2, and we can just straight away apply the value of alpha is 3 plus 9 over 2, and the result is going to be equal to 6. So that's for the first part, question A. Now let us try and answer the next question, which is related to finding the variance of the time taken to check out at the supermarket. And I'm just going to use the formula that we have painfully proved in this page. We have done this part, so I'm just going to use that formula then. Okay, now for this one here, we have variance of x according to the formula is beta minus alpha squared over 12, and beta is 9 minus 3 squared over 12. 9 minus 3 is 6. 6 squared is 36 over 12. Therefore, variance is equal to 3. So there you go. That is the value for variance. Next, let's find this one, the probability that Irene will take more than 7 minutes to check out. So probability time taken is more than 7 minutes. So we can translate that as time taken is the random variables. We're going to represent that with x. More than, that means greater than 7. And we are going to apply the knowledge that you have already gotten in the previous chapter when you talk about finding probability when you have a continuous case. Therefore, we have to deal with integration. Here we need to know what's the value of fx. So fx is 1 over beta minus alpha dx, yes. And then x is greater than 7. That means the lower limit is 7, upper limit must be 9. And this part here, beta minus alpha, we can just substitute the value straight away. We can just write down 9 minus 3, which is 6. So we have 1 over 6, 9, 7, 1 dx. Okay, oh God. Okay, so here we have, okay, and if you integrate 1, you will have x, 9 and 7. Therefore, this becomes 1 over 6. Substitute 9 and 7 respectively. So we have 9 minus 7, 2 over 6, which is equal to 1 over 3. Okay, therefore the probability that the time taken is more than 7 minutes is 1 over 3. Okay, I think that's all for now. Thank you very much for watching, and in the next video I shall be talking about the introduction of gamma distribution. Alright, see you then.